Hello everyone, I am Soumyashree here, wishing you all happy Engineers Day. So, today we will discuss about thin cylinder. In our previous classes, we have already discussed about elastic constants, numericals on elastic constants, simple stress strain, and types of strains, type of strain. Next, as we have completed our module 1. So, in our module 2, we will understand about thin cylinder. Okay. So, as we know, to store high pressure fluid, we require some metallic cylindrical structure. Okay. So, if these structures or metallic structures are not perfectly metals, or if their thickness is small or lower, then what will happen? The fluid has high pressure. Okay, so this high pressure fluid can make the metallic cylinder or any metallic pressure vessels to burst or crack into pieces. So for the perfection, for perfectly to hold or store that high pressure fluid, we require perfectly designed thin cylinder or thick cylinder. Okay, so we will learn about this. Here what it says, that thin cylinder or thick cylinder or spherical vessels are termed as what? Our pressure vessels. Okay, here. So what we do here? Okay, we just take one metallic piece and make into cylindrical structures. So by formation of these metallic pieces and the cylindrical structure, we hold or stores our that high pressure fluid. Okay. So in our next point, what pressure vessel is defined as a closed cylindrical vessel. Okay. In this closed cylindrical vessel, we hold the high pressure fluids. Okay. So as we know that those high pressure fluids, their pressure is not equal with the atmospheric pressure or what? Your ambient pressure. Ambient pressure is what? The atmospheric pressure. Here some pressure is generated. Okay, here we have some pressure, but this pressure is termed as our atmospheric pressure or ambient pressure. This pressure is rarely equals to what? Your 1 bar or very small. Okay, this can be hold, but that high pressure or high pressure fluid has more pressure than our atmospheric pressure. Okay, so to hold that we need different what? We need which type of material? Like cast iron material or our non-ferrous alloys. Okay, here like cast iron sheets or steel, non-ferrous alloys, these metals can hold the pressure of high pressure fluids. Okay, so for an example, what are the thin cylinders or thick cylinders? Here, like steam boiler, water tank, oil tank, LPG cylinder. The best example is our LPG cylinder. Why? We are in our day-to-day life, we are using that LPG cylinder in our day-to-day life. So we can easily, by that example, we can understand. Okay. So, okay. Next, how to understand? How can we differentiate thin cylinder or thick cylinder? Here, take an example, like if we don't understand, like take this notebook. Okay, so by this notebook we will understand the thickness. What is the thickness? If we take the metal sheet as like our notebook, so this is So this is the thickness of the metal. So we have the metal sheet. Now we will fold it like this. Okay, if we close this and this part, then what will we get? Like here, we can have what? Our cylindrical vessel, pressure vessel. Okay, let's imagine this thickness. After this thickness, this to this is your what? Internal diameter. Okay, can you understand this? Here we got the thickness of the metal. Then if we close this side and this side, then it will become the, imagine it as the LPG cylinder. Okay, so if we close it, the high pressure fluid will be stay here. So this, what it says, this internal diameter, here it is your internal diameter and it is your thickness of the pressure vessel. Okay, so what it says, that cylinder whose thickness is less than 1/20th time of internal diameter. That means T should be less than 1/20th of internal diameter. That we say as what? Our thin cylinder. So with this example of this notebook, we can say this is your thickness of the cylinder, metallic cylinder. Okay, the metal sheet thickness is here. So this thickness should be less than 1/20th of internal diameter. Easy? Yeah. So here is the formula written here. Okay, so your T should be less than 1/20th of internal diameter. Okay, so next you can say why we need thin cylinder. We can use high level of like metallic cylinder with so much thickness of metals. We can use like these will be greater than the diameter. Okay, here is the example. Here is our thin cylinder. Why it is said as thin cylinder? Because if I cut it here, so this is our what? T, and your internal diameter, this is your what? Di. So what we have learned? T should be less than of Di/20. If T greater than Di/20, then that cylinder is termed as what? Our thick cylinder. Okay, so our next here the question arises that why in case of why we need thin cylinder, we can use thick cylinder. But here you can see the example. Here this man holds it like this. If we increases the weight of metal, if we increases the thickness of metal, then the weight will be very big or very large. So this man cannot lift it like this. Okay, and the another purpose is for transportation also. For transportation also, we cannot use thick cylinders. So if what is our main purpose for thin cylinder? If in as much as less amount of metal we can use for to store our high pressure fluid. So next what we will understand? Okay, so as we have known that the high pressure fluid generates very big amount of pressure. So to resist that force, we need what? The metallic what? Here we use the metal, that metal, this metal and this metal also generates some resisting force. Okay, these metals also have some resistance force. So to resist these, okay, here if the pressure is here, so the pressure will apply the force like this in this direction. Okay, so here and here also. So this metallic the metal, okay, the metal which is made of any non-ferrous alloys or cast iron or steel. Okay, these metals can generate to resist the internal pressure, have some force. So these stress are called as what? Our hoop stress or circumferential stress, that is termed as our sigma C. Next is our longitudinal stress, that will be denoted by sigma L, and our radial stress. Radial stress, that is denoted by sigma R. Okay, so as first we will understand hoop stress or circumferential stress. Okay, so in a diagram here, okay, we know like this our cylinder. Okay, here, so this is the thickness of cylinder and here is our internal diameter, here is T. So in case of thin cylinder, we know what? T should be less than di upon 20, and in case of thick cylinder, it should be greater than internal diameter upon 20. For thick cylinder, here for what? Thin cylinder. Okay, so in case of top view of what? As a civil engineer, we can very confidently know about top view and front view. Okay, if we see any object from this view, okay, this is your top view. If we see the cylinder in this way, so we will see the cylinder as like this. Okay, now what we know till now, that the fluid inside the cylinder generates a very big amount of pressure. So that pressure is like this here. So also we know what? Every action has equal and opposite reaction. So the metal formed here also gives resisting force. So this metal will apply the pressure like this. For that reason, we have what? Cast iron and steel, non-ferrous alloys. Okay, also with proper thickness of material or metals. So, okay, if we cut the cylinder in half, so what is the view? The view will be like this. So first we will understand what is hoop stress here. So, okay, in case of what? Here, in case of hoop stress, what we will understand, if the pressure is applied like this, okay, the pressure is like this, so the metal will burst into how? Into like these pieces, okay, here. This is the complete metal. Okay. So, after the application of force here, what happened? The metal will burst into like pieces. Okay. So, here is our internal diameter. So, this force is termed as our hoop stress or circumferential stress. The formula for circumferential stress is equals to what? P T upon 2T. T is our what? The pressure generated inside the pressure vessel, and our D is our internal diameter. T is our what? Thickness of pressure vessel or the metals. Okay. Next, we will understand about longitudinal stress. Okay. If we cut this into, wait. So, here, the force is like in lengthwise. Okay. If the force is also in this way, inside force is like in this way. So, the resistance force will be from the cylinder and the metals like this. So, this lengthwise our force generated by the force is termed as what? Sigma L, your longitudinal stress. So, the formula for longitudinal stress is what? PD upon 4T. Never misunderstand. This is 4T. PD upon 4T. Okay. So, here one off. I have done mesh here. Yeah. So, we can see one perpendicular stress generated, that is our sigma R, that is our what? Radial stress. So, this radial stress, the magnitude of this stress is very low. So, we don't consider it in practical purpose. Okay, generally in case of calculation or numericals, by solving, when we solve numericals, we only consider about what? Our longitudinal stress and hoop stress. The main stress is our what? Hoop stress, and longitudinal stress also we consider. But normally sigma R, radial stress, as the magnitude is very low, very minute, so we don't consider sigma R. So, it is what? Sigma R is negligible. Okay. So, in our next class, we will discuss about the expression, how to derive our hoop stress and longitudinal stress. Okay. Thank you so much.